This conference will now be recorded.
So today is 14th session. So today we will discuss about managing redo log files. So what is actually redo log? We already covered in the database architecture, but again I want to tell redo log is basically the changes which are stored whatever the changes made to the database whenever it occurs, it will store in the redo log file. And by redo log file, we are basically protecting the database in case of any instance failure. So to know more about redo log, we should know about the redo threads, redo log contents, and how database writes to the redo log. So when someone is saying about redo thread, so redo thread is basically the redo log for each database instance is referred as a redo thread. So in typical configuration, only one database instance access an Oracle database. So only one thread is present. But in rack, two or more instances concurrently access a single database, and each instance has its own thread of redo. So in rack, separate redo thread for in each instance, avoid contention for a single set of redo log file, so that they are eliminating a potential performance bottleneck. Okay. Now second term, that is redo log contents. So redo log files are basically stored redo records. We called redo records as a redo entry, which is made up of a group of change vector, each of which is a description of change made to a single block in the example. So what does this mean? Suppose you want to change a salary value in employee table. So you generate a record containing change vectors that describe changes to the data segment block for the table, the undo segment data block, and the transaction table of the undo segment. So redo entries basically record data that you can use to reconstruct all changes made to the database by your statement, whether it is a DML or DDL, including the undo segment. So redo log also protect rollback data. So whenever you recover the database using redo data, the database reads the change vector in the redo records and apply the changes to the relevant block. Okay. And as I said in database architecture session, redo records basically store in a circular fashion in the redo log buffer of the SGA, and server process write the redo entries in the redo log buffer first, and from redo log buffer LGWR, which is a background process, it writes the redo records from the redo log buffer to the redo log file and assign a system chain number or SCN to identify the records for each committed transaction. Only when all records associated with a given transaction are safely written on the disk in the online redo log file, okay, the user process notified that transaction has been committed. So redo records also be written to a redo log file before the corresponding transaction is committed. So what are those cases? We already discussed. if the redo log buffer full or another transaction commit, LGWR flushes all the redo log entries in the redo log buffer to redo log file, even though some records may not be committed, because if redo is generated 1 MB, then LGWR is right. If one third redo log buffer is full, then it will write. When commit happens, then it will write. So these are the when checkpoint happen, then it will write. So these changes basically, these records basically used to roll back these changes. And now, how Oracle database writes to the redo log? So can anyone tell me, guys? See, every database has two or more redo log files, and each redo log file is stored in separate group. So we required basically two group, and every group we required minimum one redo log file. So one is why we require two, because we want one is always available for writing and other is being archived if the database is in archive log mode. Okay, so that's why we require two redo log groups, and in that we required one redo log files in every group. So LGWR writes to redo log file in a circular fashion. When the current redo log file fill, LGWR moves to the next available redo log file and it will writing, and when the last available redo log file is full, and ARCN process come and return those record to the archive redo log file. And when LGWR return back to first redo log file, and it will start writing to it. So it is working as a cyclic fashion. Got it, guys? And whenever it is moving, so every time it is assigned a sequence number to each group redo log file. So whenever it filled, and it moves to the next redo log group, and in that it start writing it will assign a sequence number. Okay, and if archive is suppose disabled, means database is in no archive log mode, so fill archive redo log file is available after the changes recorded in it have been written to the data file. If archive is enabled, then we know that LGWR moves to the next file, and after that, when it will fill, it will come back to first file again. But between that period, ARCN process writes the redo entries from the redo log file. Okay, so there is a diagram which I have actually. So let me show you this diagram. So you can see that LGWR is writing redo log 1, then move to redo log 2, then move to redo log 3, and then come again to redo log 1. So like this way it will work in a cyclic fashion. Got it, guys? Now suppose we have two members in every group, or you can say two redo log files in every group. So suppose LGWR is writing in group 1. So in group 1 it will find two redo log files. So how it will write, guys? Answer me. Whether it will write simultaneously in both the file together, or whether it will write onto one file same group then move to a next file in the same group. So like this way it will write. Tell me. Answer me, please. Hmm. Nobody want to reply? Hmm. Okay. No issues. But this is very bad actually. So there is a status for every redo log group, and in that every redo log file. So when status is current or inactive redo log file, Oracle database only use one redo log file at a time to store records written from the redo log buffer. So the redo log file that LGWR is writing to is called the current redo log file. So whenever you see current status in the query, so it means LGWR is writing on that group. And if suppose it has two files in same group, so LGWR writes simultaneously in both the group. So that was the answer. Okay. And log switches and log sequence numbers. So log switch actually is the point at which the database stops writing to one redo log file because it gets filled according to the size which you have given, and it begins writing to another. So log switch basically occur when the current redo log file is completely filled and writing must continue to the next redo log file. Okay, so active and inactive redo log files, if we talk about, so redo log files that are required for instance recovery are called active redo log files, and redo log files that are no longer required for instance recovery are called inactive redo log files. Okay. And when you are getting current status in redo log file, it means LGWR is writing on that file. So these are the status you will get when you check the v dollar view actually. So we will see later. Clear? Now, if you have enabled the database in archive log mode, then the database cannot reuse or overwrite an active online log file until one of the archiver background process has archived its content. So that time LGWR will wait if suppose writing is not finished by ARCN process. But if your database is on no archive log mode and when the last redo log file is full, then LGWR come to the previous redo log file, and it will overwriting the available redo log file in the sequence when it becomes inactive. Okay. And log switches and log sequence number. So already I said that a log switch basically is the point at which the database stops writing to one redo log file and begins writing to another one. So normally log switch occur when the redo log file is completely filled and writing must continue to the next redo log file. But you can configure a log switch to occur at regular interval regardless of whether the current redo log file is completely filled or not. So, and you can also forcefully lock switch manually. How we can do that, guys? Anyone? So if you see first command, we will see whether my database is on archive log mode or not. So archive log list is the tool command. By that you will see that my database is in no archive log mode. ARCN process is disabled, but the default destination of my archiving is Oracle home in that DBS folder and then arc folder. And my sequence number current is 20 and previous oldest one is 18. Okay. Describe the dollar database. So here also you can check. So I will say select name comma log underscore mode. Okay, so when you choose this from v dollar database, so here also you can see that your database is in no archive log mode. Got it, guys? So Oracle database assign each redo log file a new log sequence number whenever log switch occur and LGWR begins writing to it. And when the database archive redo log files, the archive log retain its log sequence number. So a redo log file that is cycled back for use is given the next available log sequence number. So log sequence number is very important. So each online or archive redo log file is uniquely identified by its log sequence number. During crash or instance recovery or media recovery, the database properly applies redo log files in ascending order by using the log sequence number of the necessary archive redo log files and redo log files. Okay, how you will plan the redo log? What are the guidelines for that? Anyone can tell me? Okay, I know you guys will not reply. I don't know why you are doing this, but that is not good. So these are the guidelines we will go and discuss one by one. First is multiplexing the redo log files, then placing redo log members on different disks, then planning the size of the redo log files, then planning the block size of the redo log files, then choosing the number of redo log files, then controlling the archive lag actually. So whenever you are configuring a database instance redo log, so you should be consider these points. So we will discuss one by one. Excuse me. So multiplexing of redo log files. So what is the meaning of multiplexing? Means we are creating a backup, or you can say we are adding another redo log files in every group, and every group redo log file we place on separate disk actually. So I will show you one diagram, you guys. That is this diagram. So here you can see that disk A and disk B is there, and in disk A group 1 member, that is log A1, and B log 1 is on different disk, and same way A log 2 and B log 2 on separate disk. So this is the way we should configure. So every group member is on separate disk. Okay, clear guys? So group 1 has two member, A log 1 and B log 1. Both are on different disk. If suppose you are losing disk A, so every group members you will not lose actually. So this is the correct way of multiplexing guys. Clear? So multiplexing is basically we are maintaining two or more identical copies of the redo log file, and these locations should be on separate disk, and the redundancy can help protect against IO error, file corruption, and so on. When redo log files are multiplexed, LGWR concurrently writes the same redo log information to multiple identical redo log files, thereby eliminating a single point of redo log failure. So multiplexing, how you will implement, we will create different groups, and in that we will create redo log file. So basically group consists of redo log file and its multiplexed copies, and each identical copy is said to be a member of the group, and each redo log group is assigned by as number like group 1 and group 2 and group 3, like in the diagram. Log 1, A log 1 and B log 1 are both members of the group 1, and both are on storing on different disk. Okay, and each member of redo log file group is concurrently active. It means it is concurrently written by LGWR, and first LGWR writes concurrently to both the member of a same group, whether it is on separate disk or it is on same disk. After that, it will write the another group, and in that each member of that group. Okay. So Oracle recommend that you should multiplex your redo log files. Clear guys? So what are the responding to redo log file and logical and illogical configuration? So we should take care of that. So responding to redo log failure actually. So whenever LGWR cannot write to a member of group, the database marks that the member is an invalid and writes an error message to the LGWR trace file and also database alert log file. And the specific reaction of LGWR when a redo log member is unavailable depend on the reason for the lack of availability. So that I have a table actually, so you can see that table. So here you see that we had four condition. The first condition, LGWR can successfully write to at least one member in a group. And what is the action of LGWR? Writing proceeds as normal. LGWR writes to the available members of a group and ignores the unavailable member. Okay, and LGWR cannot access to the next group at log switch because the group must be archived. So the database operation temporarily halt until the group becomes available or until the group is archived. So that is the waiting of LGWR. So this condition if is there, LGWR will wait and your database may be hanged. Okay, and the next condition is suppose all members of the next group are inaccessible to LGWR at a lock switch because of media failure. So what will happen? Oracle database will return an error and the database instance shut down. In case you may need to perform media recovery on the database from the loss of redo log file. So if the database checkpoint has moved beyond the lost redo log, media recovery is not necessary because the database has saved the data recorded in the redo log file to the data file. You only drop the inaccessible redo log group, and if suppose database did not archive the log or bad log, so you can use alter database clear log file unarchive command to disable archiving before the log can be dropped. Okay, so that section actually we will cover in backup and recovery workshop. And all members of a group suddenly become inaccessible to LGWR when it is writing. So Oracle database again return an error and the database instance immediately shut down. In this case, you may need to perform media recovery. If the media recovery containing the redo log is not actually lost, so suppose if the drive for the log was inaccessible, turn off, media recovery may not be needed. In this case, you need only the drive back on and let the database perform automatic instance recovery, and that will perform by a small process, guys. Remember? Okay. And legal and illegal configuration. Suppose you are placing a same group member on same disk and same group member on different disk. So that is illegal configuration actually. So what is those? Let me show you that diagram also. So you can see here a log 1, A log 2, A log 3. All these are three group, okay, and every group member is same on disk A. So that is legal configuration, right? And B log 1, B log 2, B log 3 means same group member on different disk. So this is legal, this is correct. But if we go like that, uh, A log 1 and B log 1, that is illegal. Okay, I think diagram is wrong. Okay. Okay, my bad. Diagram is wrong. Okay, so leave it the diagram. Actually, I have taken from internet. So uh, here you can remember only if you are putting every log group member on same disk, so that is wrong actually. You have to put every redo log group member on separate disk, like the first diagram which I showed. One group, one member on disk A and on disk 2. Second group, one member on disk A and second member on disk 2, like that. Clear, guys? Or any doubt? Okay, now so I already covered placing redo log members on different disks. Okay, and suppose you want to avoid contention between LGWR and ARCN while writing to the members by LGWR and reading the members by ARCN. So what should you do? You should suppose have two groups of multiplex redo log members. place each member on a different disk, and set your archival destination to another disk. Okay, so that way you can reduce the contention or avoid the contention between LGWR and ARCN. And also data files should also be placed on different disks from redo log files to reducing the contention between DBWR and LGWR. Got my point? Now, what should be the size of redo logs? How you will decide? First thing, you should know whether you will archiving the redo log file or not. So this first point you should be consider. And redo log file should be same sizes. Okay, means it does not mean that you will use different group sizes. Suppose one redo log group can fit on 49% of the tape storage capacity remains unused. In this case, it is better to decrease the size of redo log files slightly, so that two redo log group could be archived on each tape, and all members of the same multiplex redo log group must be same size. I already said that. And members of different groups can have different sizes, but there is no advantage in different sizes between groups, because if checkpoints are not set to occur between log switch, so make all groups the same size to guarantee that checkpoint occur at regular interval. Okay, so remember that. What is the minimum size of redo log file is permitted, guys? आंसर दे दो भाई. Why you are not motivating to answer my question? What should I do, guys? Let me know. Is that 200 MB? Thanks, Lakshmi. At least you respond, because from morning nobody is responding. 4 MB actually. So please note that. And what should be the block size of redo log files? Uh, as we know that block sizes are different, data file block size is different, control file block size is different, redo log file block size is different. Okay, I will not tell you because you guys are not responding, so I will not answer this question. So minimum redo log file block size is 512 bytes actually, but we had higher capacity disk drive. So if you are using that, so you will get 4K sizes also. So you can create 4K block size on those disks, and you have 1024 block sizes also. So you can choose, but the amount of redo wastage in 4K block sizes versus 512 bytes blocks is significant. So you can determine the amount of redo wastage by getting or by checking the statistics, which are stored in two views, and those views are v dollar stat and v dollar sys views actually. Okay, so let me check first block sizes for so we had two views actually mainly. So v dollar log, so here you can see that block size column is there. So group 1 comma block size uh, from v dollar log. So here my disk is normal disk, so that's why block size is using 512. bytes. Okay, so lots of DBA has confusion that 8K block size is by default, so it will be used for data file, it will use for control file, it will use for redo log file. So it is wrong conception. Okay, because you can see that redo log file block size is 512 bytes right now. Clear? Now how you will check redo wastage? So we can access v dollar sys stat. So here redo wastage is this 74820. So like this you can check, and same way another view is uh, v dollar session state. Okay, so describe v dollar ses stat. So this is another view you can check. Okay, clear? Okay, name is not there, so yeah, statistics we will choose. Mm, so this query, let me go like this. Okay, from v dollar is sysstat. Oh, two time I use. So these are the statistics actually. So here you will not get actually correct way. So you can go with the first view. Okay. And you can specify block size when you are creating database first time, and when you are altering the database, when you are creating control file statement. So there you can use actually block size. By default block size is optional actually. Okay, so you can give block size 512 bytes. By default it is. If you have fastest excuse me, if you have block size disk of 1024, then you can give block size 1024, and if you have block size 4096, then you can give 4096. And choosing the number of redo log file. So the best way to determine the appropriate number of redo log files for a database instance is to test different configuration. Okay, so optimal configuration has the fewest group possible without hampering LGWR from writing redo log information. So in some database you may require only two group, but in some cases you require more than two group. So that depends. Okay, and you can consider the parameter then that can limit the number of redo log file before setting up or altering the configuration of instance redo log file. So what is those parameter, guys? We discussed already. Anyone? First one is max log file. So whenever you are using in create database script, so if this is basically group values, and it can range from 1 to 2, 3, 4 like that, and you can exceed max log file limit. But if you are extending, so your control file also expand. So if you're not specifying max log file, then operating system default value will be chosen. And the next is max log members parameter in create a database command. So this is the another parameter which actually uh, the maximum numbers of members for each group, and the only max log file is the only way to override this upper limit actually. So it is important to consider this limit before creating database. If you are not specifying this, it will use operating system default value. Clear, guys? Now, archive lag. So there is a parameter for that. If I ask you guys, you will not reply. Okay. So show parameter archive lag target. So see that it is 0. So basically, you can force all enable redo log threads to switch their current logs at regular time interval. So basically, this parameter has better use when you are configuring data guard. So whenever changes are made available to the standby database by archiving redo logs at the primary site and then shipping them to the standby database. So the changes that are being applied by the standby database can lag behind the changes that are occurring on the primary database. So the standby must wait for the changes in the primary database redo log to be archived in the archive redo log and then ship it to. So to limit this lag, you can set this initialization parameter. So you will specify in a second and how long the lag can be. Okay. So uh, so when you set archive lag target initialization parameter, you cause the database to examine the current redo log file, current redo log for the instance periodically and determine when to switch the log. But for that, we require some conditions should be match actually. So the current log was created before n second ago and the estimated archival for the current log is suppose m second. Okay, so n plus n plus m will be the value of the archive lag initialization parameter. Okay, and second, the current log contains redo record. So in rack environment, instance also causes other threads to switch and archive their logs if they are failing behind, because this is useful when one instance in the cluster is more ideal than the other instance. So archive lag target parameter basically provides an upper limit for how long in second the current log of the database can span. Okay, and by which way you can set like archive lag target is equal to 1800, and if suppose 0 is showing, then it will disable time based log switch functionality. So you can set archive lag target in initialization parameter even if there is no standby database also. Okay, so by alter system command, you can set this parameter. Okay, and for rack, you should set the same value for all the instances. Okay, and what factor basically affect the archive lag target? So factors are there are many factors. So first one is overhead of switching logs. How frequently normal log switch occur as a result of redo log full condition. How much redo loss is tolerated in the standby. So these are the factors we should take care of that. If suppose I am setting very low value, then it can be negative impact on performance. And if suppose we are setting some reasonable value so as not to degrade the performance of primary database. Okay. And if you are setting this parameter, so it not be very useful if natural lock switch already occur more frequently than the interval specified. Okay. Now, how to create redo log groups and members? So as I said, we had a parameter max log files, we had a parameter for max log file members, right? So these two decide basically the group and members. So you should plan before creating the database, means how many groups you required, how many members you required in each group. Okay. Later you can also create, but better to go with same when database creation. So let me check you guys how many redo log groups we have. So describe v dollar log. So select group comma members comma status. Okay, members I'm not taking right now. I'm just group and status from v dollar log. So see that we are creating, or we created database through DBCA. So three group will be created. And now see that first group status is showing inactive, second group is showing current, third group is showing inactive. So LGWR is writing on which group, guys? Answer me. Nobody is answering. Wow. Okay, no issues. We had to show you practically number, please. It's group 2, right? So you should say group 2. Answer is like that. Thanks, Lakshmi. At least you respond. So we will continue on next session because already 1 hour passed, and today morning I have already taken 7 to 8 a.m. My data guard session actually. So now I can continue more than 1 hour. It's not good for you and for me also. So right now I'm stopping here. The next thing we will cover in next session, because redo log file is very important. So we should cover everything in that. Okay, whether I'm giving free session or whether I'm giving paid. Actually, my method is same. Okay. So thank you guys joining for this session, and thank you for not answering my question. Okay, I am stopping the recording. Okay.